Hello, grade 12s. Guys, I have interesting question of November 2023, question 9. We are going to be talking about proportionality theorem. So let's check. Let's see this question 9 of November 2023 and see how it goes. So the first thing that we do, we read the information. In the diagram, ABCD is a parallelogram. So let us observe our parallelogram. They are saying A, B, C, D. It's a parallelogram. So this shape here, this shape here is a parallelogram. Right away, it is very, very important, guys, to know the properties of a parallelogram, because the examiner says A, B, C, D is a parallelogram. So what are the properties of a parallelogram? We have to remember that the opposite side of a parallelogram are parallel. So since AB is opposite to CD, so I'm going to say AB is parallel to CD. And I'm also going to say the side AD is parallel to the side BC. So this is one of the property of a parallelogram. Opposite sides of a parallelogram are parallel. Actually, they are not only parallel, they are parallel and equal. So let me give you, let me give you a shape, a quadrilateral, which I will state that it's a parallelogram. Let's say we have got a quadrilateral of this nature. Let me call it E, P, Q, R. Now, let me say this EPQR, it's a parallelogram. Okay, this means that the opposite sides are going to be parallel. Remember, the opposite side of a parallelogram are parallel. This means that the side EP is parallel to the side RQ, and the side ER is parallel to the side PQ. Opposite side of a parallelogram are parallel. Now, the opposite sides are not only parallel, but they are also equal. So if I say the side EP, it's 15 centimeter. If I say to you EP is 15 centimeter, it means that even RQ is going to be 15 centimeter, because the opposite side of a parallelogram are parallel and also equal. So we can say EP is equals to RQ. And we can also say that ER, the side ER, this side, is also equals to the side PQ. So if I say ER is 5, it means also PQ is 5. These are the property of a parallelogram. Opposite sides are parallel and also equal. Actually, this is the property that I want to focus at. There are other properties such as diagonals of a parallelogram bisect each other. Opposite angles of a parallelogram are equal. But for now, I just want us to focus at this property. Opposite side of a parallelogram are parallel and equal. This property is going to be useful in this question 9 of November 2023. So let's go back to the reading of the problem. What are they saying? They are saying in the diagram, ABCD is a parallelogram, which means remember we said the opposite side are parallel. Now, opposite sides are not only parallel, I have a right to say DC is equals to AB, because DC is opposite to AB. I also have a right to say DA is equals to CB. These are the opposite side of a parallelogram, are parallel and equal. Now, they went again and they said AB is 14 units. So they are saying the distance from A the distance from A to B, this distance AB, it's 14 units. So the distance from A to B, it's 14, which means that the distance from D to C, it's also 14, because these are the opposite side. Remember, we said opposite side of a parallelogram are equal. So once they say AB, it's 14, automatically DC also, it's 14. And what else? They are saying AD over DE, it's 4 over 3. I'm going to talk about that. And they are saying EB intersect DC in F, EB is equals to 21 units. So I'm also told that the distance from E to B is 21 units. So this distance from E to B is 21 units. Okay. The first question say calculate with reason the length of FB. Calculate with reasons the length of FB. So I'm going to do this. The first thing that I want you to spot now, it is the triangle EAB. This is the triangle I'm going to focus at. The triangle EAB. So let me show this triangle with a red color ink. The triangle EAB. This is the triangle I want us to focus at. Now, very, very important. You have to see that in a triangle EAB, there is a line which is drawn parallel to one side of a triangle. So every time when you have a line drawn parallel to one side of a triangle, you know that you are going to use what we call proportionality theorem. So let me draw this. Let me say we have a triangle. Let's say this triangle is triangle EABC. Now, if I draw a line parallel to one side of this triangle, remember a triangle has got three sides. So in this case, let me draw a line parallel to AB. Let me say there is a line, and I say this line is parallel to AB. Let me call this line EF. Now, I'm going to use proportionality theorem here, because I have a line drawn parallel to one side of a triangle. Every time when you have a line drawn parallel to one side of a triangle, you have to think of proportionality theorem. In this case, you have a right to, let's come, now this side, okay, this side is parallel to this line. So I'm going to focus on these two sides of a triangle. Okay, for simplicity, let me do this. Excuse. For simplicity, let me do this. Let me say I have ABC. I have a line drawn parallel to one side of a triangle. This line is parallel to this side. So now I have, let me say EF here. I have this side and I have this side. I have the side AB and I have the side AC. So what I'm going to do, I'm going to say AE over EB. So I'm going to apply the same thing which I did on the side of AB. I'm going to apply it on the side of AC. I'm going to say AF over FC. So this is my proportionality theorem. So whenever a line is drawn parallel to one side of a triangle, you have to know that the other sides will be in proportion. So that is why we say, okay, AE over AB is equals to AF over FC. This is a proportionality theorem, and you will see how this prop theorem will help us to calculate the length of FB in question 9. So let me take you back to question 9 of Euclidean geometry. I have this triangle. I have this triangle EAB. I have this triangle, and I have a side drawn parallel to one side. I have a side drawn, I have a line drawn parallel to one side of a triangle, this line. So this is parallel to this. It means this two other side. It means EA and EB, they are going to be in proportion. So you are going to say ED over DA is equals to EF over FB. You can do that, and you can apply proportionality theorem differently. You can apply it differently. You can even say, let's start on the side of EC. You can even say FB. So I started with this one. I started with FB. I said FB. So you can say FB over EB equals to, now you say, I said FB over EB. It means when you go to the other side, you say DA over EA. Yes, DA over EA. Make sure that what you do on this side of EB. So if you start with FB, it means on the other side, you're going to start with DA. So if you say FB over EB, even when you come this side, on the other side, you have to say DC. You follow the same procedure. You say DC over EC, and this is what we call proportionality theorem. Make sure that you write the reason prop theorem. So you can apply proportionality theorem differently, or you can even decide to start with EA. Yes, E or EF. I already started with EF. You can even say EB. You can even say EB. You can apply it the way you want. You can say EB over EF equals to EA over DC. The reason is still proportionality theorem. You make sure that you write the reason. Proportionality theorem. So now here, let's read the information. Now here they said AD over DE. They said what? They said AD. They said AD over DE. So they gave me AD over DE. And I know that AD over DE equals to, I will do the same thing on the other side. I will say a BF over FE. BF over FE. My reason is prop theorem. It's a prop theorem. So I know AD over DE. AD over DE, it's given. AD over DE, it's 4 over 3. So I will say 4 over 3 equals to, I'm actually now attempting 9.1, where they say calculate the length of FB. So FB or BF, I need it. So I will say FB over, unfortunately, I don't have the value of FE. They gave me the length from E to B. They gave me the length from E to B. I don't know the length of FE. I know the length from E to B. So what I'm going to do, I'm going to do this. I'm going to say EF plus FB. Oh, let me write neatly. So I'm going to say EF plus FB is equals to 21. Or let me say it's equals to EB so that you will follow, equals to EB. So I'm saying the length from E to B is made up of two portions. It is made of EF plus FB. So the whole EB, it is made up of EF and FB. So now I'm going to say, okay, EF plus FB. Remember, EB is 21. So EF plus FB, the whole EB is 21. 21. And make EF the subject of the formula. So I'm going to say EF is equals to 21 minus FB. Take FB to the right-hand side. So you say EF equals to 21 minus FB. So I'm going to substitute this EF or FE with 21 minus FB. Now I have got only, if you look at my equation there, 4 over 3 equals to FB over 21 minus FB. I've got only one unknown, which is FB. So it's going to be easy to find the length of FB. So proportionality theorem was very useful in this case. So from here, I'm going to do cross multiply. I'm going to say 20, where can I even write here? Because I'm running short of space. Let me, after cross multiply, so I'm going to say 4 times 21 minus FB. It's equals to 3FB. Now 4 times 21, it's 84. So I'm going to say 84 minus 4FB is equals to 3FB. Group like terms, 84 equals to, we're going to take 4FB to the other side. So it's going to be 3FB plus 4FB. Therefore, 84 is equals to 7FB. Now you can divide both sides by 7 to find the length of FB. So FB is going to be 84 divided by 7. Just press that on your calculator. 84 divided by 7. You will get the length of FB. So that was the problem of 9.1. The proportionality theorem was very helpful. So you go for proportionality theorem whenever you see a line drawn parallel to one side of a triangle. So for the last time, let me show you the instances where you use the proportionality theorem. For the last time, if you have got a triangle and then you have a line parallel to one side of a triangle, like this, they say this. So you see that here you have to use proportionality theorem because you have a line drawn parallel to one side of a triangle. Every time when you have a line drawn parallel to one side of a triangle, you can think of using a proportionality theorem. So now I'm going to 9.2 on 9.2, let me see, they say prove with reasons that EDF is similar to EAB. So I have to prove that the triangle EDF is similar to the triangle EAB. Now, proving similarity of triangle, it's very simple. You just look for the angles that are equal. So in this case, they are saying, actually they are saying EDF, they are saying prove that EDF is similar to EAB. So what you do, you look for the first angle. So I will say look for E in EDF and check if it's equals to E in EAB. So those letters that they wrote first, check the equality of their angles. If they started with E in triangle EDF, you take that E, you check if it's equals to E in the other triangle, so in the triangle EAB. So proving similarity of triangles, it's simple. You just focus on the angles. This is the instance where we check whether the angles are equal. So this is E is the first in EDF. E is the first in EAB. So you check whether these two angles are equal. Angle E in EDF, you check if it's equal to angle E in EAB. This is how you can prove similarity. So let's check E in EDF. So we're looking at the triangle EDF. So this is our angle E. This is our angle E in EDF. So let's look for angle E in triangle EAB. If we go to the triangle EAB, EAB, we notice that the angle E is common. It's a common angle. It is found in both our triangle. If you go to the triangle EDF, the angle E is the same angle E in the triangle EAB. So we are saying, is this the same, is the common angle? So I'm going to say, okay, E, angle E, let me just say D here and F here to show what I'm talking about. E from the triangle EDF or from the triangle DEF, and say it's equals to E, which is in the triangle AEB, or you can say in EAB, those E, then we say that this is the common angle. These two angles are equal because it's a common angle. Now, let's check if D is equals to, let's check if angle D in EDF is equals to A in EAB. So let us D in EDF. So let me erase here and look for D in EDF. So in EDF, so the angle D in EDF, we are checking if it's equals to A in EAB. So let's check EAB. EAB, this triangle here. Yes, so we are checking for reason why could the angle D here is equals to the angle A here. And we say these two angles are equal because these are the corresponding angles. They are forming an F shape. Remember, they said this line, it's parallel to this line. So which means we can look for the angles that form an F shape. The angles that form an F shape, they are corresponding angles, and corresponding angles are equal. So I'm saying DF, it's parallel to AB. So here I'm having what we call a transversal line. A transversal line is the line that passes through these two parallel lines. So this is my transversal line. Now I say the angle here is equals to the angle here. If you observe carefully, the shape which has been formed there is an F shape. So we are going to say, okay, the angle D and the angle A are equal because these are the corresponding angles. Angles that form an F shape are corresponding angles. So I'm going to say, okay, it was E. Yes. Now here I'm going to say the angle D, you can say D. Sometimes it's important to specify D in which triangle. So you can say E and you say F. In triangle EDF, D is equals to A in which triangle? In EAB. Why is this angles equal? Corresponding angles are equal. So these are the corresponding angles. That is why they are equal. Now, because I have shown that two angles are equal, I've shown that one angle from the triangle EDF is equals to one angle from the triangle EAB, and I did it with the second angle. So I've already shown you that two angles from one triangle is equals to two angles from the other triangle. So what I'm going to do, the third one, I'm not going to even try to prove it. I'm just going to state it. I'm going to say, okay, I've talked about, in the small triangle, we have talked about E and D. So we are left with F. So we're going to say the angle F. So it's still EDF equals to angle B. In which triangle? In EB. You can say EBA. This is the third angle of a triangle. Therefore, the triangle EDF, it's similar to the triangle EAB. So I have shown you that the two triangles are similar simply by working with angles, by showing you that we have got angles that are equal. So guys, I'm going to summarize this for the last time. If we ask you to show, let's say something like this. If we say prove that the triangle EPQ, it's similar to, maybe let's say ERM. What you have to do, you have to check if angle E is equals to angle E here. And you have to check if angle P is equals to angle R here. Once you get two angles that are equal, you are done. The third one, you just state it. So it's easy, guys, to prove that two triangles are similar. You just focus on the equality of angles. You just show us the angles that are equal. So now I'm going to go for 9.3, which says calculate with reason the length of FC. Maybe I should have tried to increase. Yes. Calculate with reason the length of FC. So how am I going to calculate the length of FC? Let's check the length from F to C. So we are looking for the length of FC. Here now, experience is very, 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 very helpful. Why am I saying this? I'm answering the question of 9.3, but most of the time I know that mathematically, the answer, the solution of 9.2 can help you in solving the problem of 9.3. The solution of 9.2 can help you in solving the problem of 9.3. How so? In 9.2, we have proven that the triangle EDF is similar to the triangle EAB. So on 9.3, I'm going to apply something very important. I'm going to apply this theorem that says corresponding sides of similar triangles are in proportion. Corresponding sides of similar triangles are in proportion. So let me show you what you do here when you are answering the problem of 9.3. I'm going to say, okay, on 9.2, I have proven that EDF is similar to EAB. This is proven on 9.2. Now I'm going to do this. I'm going to say ED, I'm picking ED here. I'm going to say ED over, then I will pick EA this side. I'll say EA equals to, now here I'm picking DF. So I will say DF. Now I'm picking AB. DF over AB equals to, now I'm picking EF. EF over, now I'm picking EB. EB. What I'm doing here is the idea that corresponding sides are in proportion. Corresponding sides of similar triangles are in proportion. Now I want to calculate FC. I want to calculate FC, and remember, I know DC. Let's not forget that we know DC. The length from D to C, it's 14. How do I know? Because they told me that the length from A to B, it's 14. And I know that these two sides, DC and AB, they are equal. Why is these two sides equal? Because these are the opposite sides of a parallelogram. Opposite sides of a parallelogram are equal. So DC equals to AB. If AB is 14, which is what we have been told, then DC also is 14. They want us to know the length of FC. They want us to know the length of FC. But now, if I can find the length of DF, I will be able to find the length of FC, because I know that DF plus FC is DC. DC is made up of the distance from D to C is made up of DF and FC. And I know that DC is 14. So DF plus FC, it's 14. So they want me to find this FC, but I'm saying if I can find DF, it will be easy to find FC, because I know DF plus FC must give me 14. Let's say DF maybe is 2. So it means FC is going to be 12. Okay, so for now I want to calculate DF. So I see that on the corresponding sides of similar triangles are in proportion. What I've stated here, what I've written here, I see that there is DF. There is this DF. So I'm going to pick DF over AB. So what else am I going to pick? ED over EA. Yes. So I'm going to pick these two guys here. You just have to pick 2. So I'm going to say ED over EA equals to DF over AB. I'm taking this one from the idea, from this theorem that says corresponding sides of similar triangles are in proportion. So I'm going to say ED over EA is equals to DF over AB. Don't forget to write the reason. Corresponding sides of similar triangles are in proportion. So do I know ED over EA? No, I've been given AD over DE, not ED over TA. So what I'm going to do this. Remember, this information here is going to be important. We are told about AD over TE. So they are saying AD over DE, it's 4 over 3. So AD, I'm going to say AD, it's 4x. Just put next to this 4, just put x. And then DE, I'm going to say it's 3x. Most students, they do this. They say DA, it's 4. This is wrong. DA, they say DA, it's 4, and DE, it's 3. Yes, they say because they told me we're AD over DE, it's 4 over 3. They are thinking that AD, it's 4, and DE, it's 3. What you have been given there actually is not the length of AD. You have been given the ratio. So the right approach, you can say AD, it's 4x, then DE is 3x, which means that ED over EA, I'm going to continue here, which means that ED, I'm going to say it's 3x over EA. EA is from here, from E to A. So it's going to be 3x plus 4x. It's going to be 7x is equals to DF. It's what I'm calculating. DF over AB. So I know that AB is 14. I've been told from the information that AB is equals to 14 units. Okay, so here I'm going to do cross multiply. So even before I do cross multiply, I can just say this x here cancel x. So I'm left with 3 over 7. So it's going to be 3 times 14. I wonder how much is 3 times 14? 14, 28, 42. So it's 42 equals to 70F. Then you divide both sides by 7. You divide both sides by 7. So I wonder how much is 42 divided by 7. It's 6. So DF, it's 6. I'm hoping I'm right. 42 divided by 7. I know that 7 into 21 goes 3 times. So it is DF, it's 6. Now, if DF is 6, it's now easy to find FC. Remember, we said DF plus FC is 14. So if DF is 6, FC is going to be 8. So you found the length of FC. So this question 9 of November 2023, it's very interesting because it's working with number 1, proportionality theorem. Number 2, it's working with corresponding sides of similar triangles. It is giving us some ideas about a parallelogram. Do not forget the properties. Do not forget the properties of a parallelogram. So hopefully you found this question very useful. And then I wish you all the best with your metric. And then hopefully you will write very well. Let me end my meeting. See you next time. Bye-bye.